It's an SI unit, just like a kilogram is for mass. The mole is defined against a known standard, so for us now we use carbon-12, and it is the number of atoms in exactly 12 grams of carbon-12. The mole, so we have a symbol for the mole, and that's a small n. The units are MOL. So the symbol for a mole is small n, and the units are MOL. When you write out your answers are going to include a number and a unit. It is a very important quantity in chemistry. It's a unit that represents the amount You're going to see that word a lot. Amount. So if something is asking for an amount of something, they're asking for the number of moles. So it represents the amount of entities or particles of a substance. Chemists deal with extremely small entities like atoms and molecules, so we need a number to make counting them practical. If there's about 100 green peas in a cup, like a coffee cup, Avogadro's number, this 6.02 times 10 to the 23, this number of peas would cover the Earth's surface 1 meter deep times 250 Earths. That's how many peas are in a mole of peas. So they would cover the Earth, 250 Earths, a meter deep. So that's a lot. 6.02 times 10 to the 23rd is also called Avogadro's number. In honor of Amedeo Avogadro. It is the number of particles in 1 mole of a substance. So Avogadro's number has a symbol capital N, lowercase capital a, and its units are particles per mole. So the particles change depending on the type of substance. So an example of a diatomic element could be hydrogen. Give me an example of a monoatomic element. You got a lot to pick from because that's a diatomic. Sulfur. Okay. Any metal would have done. Most nonmetals. Okay, so if you are a monoatomic element, your type of particle is atom. If you are a diatomic element, your particle is molecule. There's no abbreviation for atom. But for molecule, we often abbreviate it to molic. H2O, water. The type of particle is a molecule. Again, short form is molic. Ionic compound. Give me an example of an ionic compound. Anything. Yep. Sodium chloride. Okay, the particle for an ionic compound is a formula unit. or an FU for short. We have 6.02 times 10 to the 23 molecules per mole. So then what's the number that goes with the mole? It's between 0 and 2. 1. We don't have to write the 1, but that's what it means. So this is Avogadro's number for nitrogen. Neon. So Avogadro's number is 6.02 times 10 to the 23 atoms per mole. Avogadro's number is, what's the unit? 6.02 times 10 to the 23 atoms per mole. The number of particles. Small n is the amount of moles. And capital Na is Avogadro's number. 6.02 times 10 to the 23rd particles per mole. So when you do questions, you have to substitute in the particle. So you have to read the questions carefully. Mathematically, the number of particles is equal to the number of moles times Avogadro's number, bless you. So the number of particles is equal to the number of moles times Avogadro's number. For those of you that have trouble rearranging an equation, you can use a magic triangle. It's magic. How many molecules of water are there in 2 moles of water? So what do we know? What letter are we given in the question? Which one? Little n. We know n is equal to 2 moles. And it says it wants to know how many molecules of water. So we've got a covalent compound. So the particles are going to be molecules. If you see how many, you're looking for big N. Okay, we know this number. Now, the units for Avogadro's number are going to be molic over mole. So big N, small n times Na, 2.0 mole times Avogadro's number. Put in your units. Do not leave them out. What happens here, if you've got a unit on the top and a unit on the bottom, they're going to cancel. This will let you know if you're doing the right math if you end up with the right units. So if we cancel those moles, we're left with molecules, which is what we want. So our answer is I strongly advise that you set up questions like this. Identify what you know, set out your formula, do your math, write out the unrounded answer, then write out your rounded answer, because that way you can at least get part marks if you mess something up. This answer would be worth 2 marks. 1 mark for the number, 1 mark for the unit. What's 2 times 12? So it adds an extra factor. So we're looking for moles. We always know Avogadro's number. And the units, the particles, because it's carbon dioxide, it's molic per mole. So, small n is equal to big N divided by Avogadro's number. Okay? The molics will cancel. And if you're dividing by a fraction, that's the same thing as multiplying by the inverse fraction. So our final units are moles. What's the number? 3.0 mole. Okay. 0.50 mol. It's iron, so what are the particles in Avogadro's number? But what's the particle? It's iron. It's monoatomic, so it's atoms of Fe per mole. So now we're looking for big N. So, our answer our units mole cancel. One's on the top, one's on the bottom. How many significant digits can you have in your final answer? 2. Because there's 2 here. So 3.0 times 10 to the 23 atoms of Fe. Avogadro's number, the particles are going to be molecules per mole. So for every 1 mole, we've got Avogadro's number of molecules of water. So always look, what is the substance that we have moles of? Because that will determine what particle goes into Avogadro's number. So, big N is equal to 4.0 mole times 6.02 times 10 to the 23 molecule of H2O per mole. So what's our answer here? So we've got 2.408 times 10 to the 24 molecules of water. Yes, except we're not finished yet. Do we have the right units?
Yes.
No, because what is the question asking for? Atoms of hydrogen. But we've got molecules of H2O. Is there a relationship between the number of atoms of hydrogen and a water molecule? It's a 2-to-1 ratio. There are 2 hydrogen atoms for every 1 molecule of H2O. So, if I multiply that ratio times my answer, molecules of H2O disappear, they cancel. The units that I'm left with are atoms of hydrogen, so 4.816 times 10 to the 24 atoms of hydrogen. And now we have to round because this is our final answer. So 4.8 times 10 to the 24 hydrogen atoms. Okay? Never round off your answer if you're using that number again. It introduces rounding errors in your final answers. So, if you are going to finish with the 2.4 times 10 to the 24, fine. And you can even write that out, round it off. But when you use it again, you're going to use the 2.408.